Alright guys, so today we're going to start doing some solving radical equations, but more like the advanced problems. But let's take some deep breaths, okay? It's just a little algebra. It's going to look way scarier than it is, but if you can do basic mathematical operations, you should be good to go, okay? So what makes these the advanced types of problems? Well, if we go back and look at our process from the other day, the first thing we're trying to do is isolating the square root. The problem that we're going to have with this one is that we can't just isolate the square roots. That's why there's that little asterisk guy right there. But it's also not going to be the case like yesterday, where we had one radical on each side, but there was only one radical on each side. So you could kill two birds with one stone. So what we have to try to do is use exponents to remove at least one of the square roots, but there's still going to be one left over. Well, how do we get rid of a square root? We square it, but before we do that, we have to isolate it. So it's kind of like we're really doing the problem 1.5 times, but once we kind of get into the middle of it, you'll see that it's not nearly as intimidating as it might look at first. So we're going to work our way through 3 example problems, okay? So the first one we have here is example 1, where we have the square root of x plus 1 equals the square root of x plus 7. You can see here this is going to be one of the advanced problems because we have a square root over here on the left and we have a square root over here on the right, but I can't exactly just square root both sides and get rid of both of the square roots. All right, so what do I need to do? I need to get rid of one of the square roots. Absolutely everything on the right-hand side of the equation is underneath the radical. So if I go and square this side, it will get rid of one of those radicals. But the golden rule of algebra is whatever you do to one side, you have to do to the other side, okay? So we're going to actually end up with a binomial over here that we're squaring. Looks 10 times worse than it is, okay? So just friendly reminder that root x plus 1 quantity squared is the same thing as root x plus 1 times root x plus 1. So I'm just going to go ahead and write that out, okay? Then on the other side, we know that the square and the square root are inverse operations, so they will undo each other. And all I'm left with over here is x plus 7, okay? But I have to go and simplify what was on this side of the equation. And to do that, I'm just going to use the distributive property, okay? So the square root of x times the square root of x is, by definition, just x. The square root of x times 1 is just 1 square root x. 1 times the square root of x is also the square root of x. And then 1 multiplied by 1 is obviously just 1, okay? So we're just using the distributive property. We've done a lot of this type of multiplication, maybe not with the square root, but you can figure it out, okay? If I simplify what's over here on the left-hand side, I end up with x plus 2 root x's, because I have 2 of them, and then plus 1, and that equals x plus 7. So in this case, now I only have 1 radical. I had 2 radicals, now I just got 1 radical. So let's isolate it, and then let's solve it, okay? So I'm going to start by saying, all right, well, if we're going to isolate it, let's subtract an x from each side, and let's subtract a 1 from each side. So I'm going to get 2 root x equals 6. So then I'm going to get that root x will equal 3. And then if I square both sides to get the x all by itself, I end up with a solution where x will equal 3 squared, which is 9, okay? But I need to go and check this, okay? Just like the other day, we're always going through and checking. So if I plug in 9, I'm really asking the question, is the square root of x, so in this case the square root of 9, plus 1 equal to the square root of 9 plus 7? Well, the square root of 9 is 3. So I'm asking, is 3 plus 1 the same thing as the square root of 16? Well, 3 plus 1 is 4. The square root of 16 is 4. So yes, it does work out. Okay, so this is kind of the part that looks a little bit intimidating, but really what we're doing, we're going to start by squaring both sides because that's going to allow us to eliminate one of the radicals. I'm going to have some algebraic operations to go and do over here that are going to involve radicals, but it's okay because we can put on our big boy and our big girl pants. Then we're going to realize that we've now simplified it down to where it just has one radical. So isolate it, square it, solve it, check it. All right. So let's go take a look at another one. So for this problem, we have the square root of x plus 9 equals the square root of x plus 2. Again, this problem is going to look very, very similar to what we just did because we have a radical on the left, we have a radical on the right, but we can't just get rid of them both at the same time. But I can get rid of the one on the left this time, okay? So all I'm going to do is I'm just going to go and square both sides, okay? But I'm going to square all of both sides. So inversely operations, so square roots and squares, so we end up with x plus 9 equals, and I'll go ahead and write this out again because I feel like you guys probably think that's easier, x plus 2 times root x plus 2. Okay, using a little distributive property, the square root of x times the square root of x is, by definition, x. And then we have plus 2 root x, then plus another 2 root x, and then 2 times 2 is 4. Okay, so this turns into x plus 9 equals x plus, if I have 2 root x's plus another 2 root x, I have a total of 4 root x's plus 4. So now we've just got this one radical here, so let's go ahead and isolate it. So let's subtract an x and subtract a 4 from each side. So we end up with 5 equals 4 root x. And then to get the root x by itself, I need to divide by 4. So if I scroll down a little bit, I end up with 5/4 equals the square root of x. Well, that's a fraction. Okay, cool. You got a fraction. Whatevs. So now we can go through and square both sides. Okay. Hopefully you guys remember what's called the power of a quotient rule. So if you have 5/4 squared, it's 5/4 times 5/4. So really what this is this is turning into x equals 5 squared, which is 25, over 4 squared, which is 16. Okay. Now you can go through and leave that as a improper fraction, or if you want to, grab a calculator. Just type in 25 divided by 16, and you get 1.5625. Okay, it's a little bit easier to type that into the calculator when we're doing the checking part. I'm okay if you put either one of those answers, but again, it's probably easier to type in the 1.5625 when we go and do the checking part. Okay, so I think I've got that. I think it looks good, but I'm still going to go up here and I'm going to check it. Okay, so I'm going to go and ask the question, is the square root of 1.5625 plus 9 equal to the square root of 1.5625 plus 2? Okay, is that a true statement? Really, I want to go through and I want to use the calculator to go through and do all this fun stuff. Okay, so I'm literally in my calculator going to go and type in the square root of 1.5625 plus 9, and that's going to give me 3.25. Then I'm going to go on the right-hand side and say, well, what is the square root of 1.5625 plus 2? So I get 1.25 plus 2. And is this a true mathematical statement? Is 3.25 equal to 1.25 plus 2? It is, so that's a valid answer. Everything works out. Okay. Could I have gone and typed in 25/16? Sure, but that's just weirder to type into the calculator. So for these problems, go with a decimal. I think it's probably easier. All right, so let's go take a look at the third and final example here. So it looks like all the other ones. The square root of x minus 10 equals the square root of x plus 2. So we have a radical on the left, we have a radical on the right, but we also have this pesky number that's hanging out over here that makes it where squaring both sides doesn't just immediately eliminate all of the radicals, okay? But it will eliminate at least the one that's on the right. So guess it's time to go through and do some mass squaring. All right. So again, this is going to end up being the square root of x minus 10 times root x minus 10. And that's going to equal squares and square roots are inverses, so that's just x plus 2. Okay. This little guy over here, root x times root x, x. And then we're going to have minus 10 root x minus another 10 root x, and then plus 100. Okay. Again, where am I getting this from? We're just using the distributive property here. Okay. And that'll be equal to x plus 2. Let's combine those like terms. So we have x, and then we have minus 20 root x's plus 100, and that'll equal x plus 2. Now we get to go and isolate the rad x here. Okay, so I'm going to subtract an x, and I'm going to subtract 100. So we end up with negative 20 root x equals negative 98. Divide both sides by negative 20, and we get the square root of x equals negative 98 over negative 20, which, let's go and do a calculator. Negative 98 divided by negative 20, remembering a negative divided by a negative is a positive, gives me 4.9. Well, that's kind of easy. Okay. So negative divided by a negative is positive, so we get positive 4.9 over here. And then if I go and square both sides, well, then I get x equals 4.9 squared, which is 24.01. Okay. Again, what are we doing? We're going to go and we're going to square some stuff. All right. So I think 24.01 is my answer, but I got to check it. Okay. So let's go through and plug it in. So I'm asking, is the square root of 24.01 minus 10 equal to the square root of 24.01 plus 2? So let's go to the calculator and do this, because I don't know about y'all, but I don't know what the square root of 24.01 is off the top of my head. So square root 24.01, and then to that I'm going to subtract 10. So I get negative 5.1. And I'm asking, is that equal to the square root of 24.01 plus 2? So calculator. And the square root 24.01, add 2 to it while it's still inside the radical, and you get positive 5.1. Is a negative value equivalent to a positive value? Methinks not. So guess what? This does not work. This is what we call extraneous. Okay? So this equation has no solution. Okay? Translation, there's no value of x that will make that a true statement. Okay? And that's the reason why we've always got to go through and check your work, because sometimes you end up with these cases where you can find it algebraically, but it doesn't actually work when you plug it in. And that really has to do with the fact that negative numbers squared become positive numbers, etc. Okay? So if you end up in a case where a negative value equals a positive value, does not pass the check, does not work, it's extraneous. Okay? So All of the problems that you guys are going to have to do on your assignment look pretty much exactly like this. You're going to see that there's two radicals, but that you can't isolate it and that you can't just eliminate both of them in one step. It takes multiple steps to eliminate. You're still going to start by trying to square both sides because ultimately, what are we really trying to do? Get rid of one radical. If you can get rid of one, simplify it, move some stuff around a little bit, and then get rid of the other one, you're going to be in good shape.